in a written format only. After you writing the letters, scan them up and then send them to my mail, quoting your mail ID, quoting your numbers. I will read out the numbers and the percentages. Some of you might be present here, you may note down. Some who are not present here, their friends may kindly note down and inform them. 353 with 40%, 357 with 63.44%, 366 with 42.73%, 371 with 53.64%, 373 with 46.36%, 356 with 66.36%. Ensure that all these people are able to send letters to my mail. Write them in hand on a paper, get it signed by your parent as well as yourself. Give clear-cut reasons and how you are going to ensure that your attendance is going to be regular now on, because you are staying back at your places and we are not forcing you to show your video even. Okay. Anyway, please take care of yourself, be safe, and start attending the sessions on regular grounds. None of you should fall below 80%. Okay. So that doesn't mean that you should not cross 80. So look for the possibility of getting 100% attendance, because wherever you are, what you need to have is you need to carry your device which you are using to attend the sessions, and ensure that the net facility is available at all those places. Okay. So anyway, nice to see you every day. I have started my presentation. So where we have stopped, I think.
This is the spot we have stopped, sir.
Okay, let me go back by 2 slides. We had been to some location. Hardly we are going back by 2 slides and discussing. So this is actually about the geared DC motor. We have got 3 sketches. These are the maybe the bottom sketch, whatever you are trying to refer. Those are the kinds of drives, what geared DC motors that have been put in use in toys. Now, one particular question I would like to put forward to you. Try to identify the manufacturers who are all manufacturing at least one out of these 3 parts in India. This is the target what I am trying to give you. This is a target for you all 61 or 62. That might be the DC motor, that is what that has been used for toy, the bottommost one, and the center one actually pretty good, pretty nicely useful for using it for cars, maybe simple cars, and for 2-wheeler, even for that it is helpful. The other one, the first one, is actually pretty good, nicely suitable for maybe small size mobile units, maybe in robo actuators also can be put in use. The basic target what I'm trying to give you for today is, out of these 3, identify the manufacturer pertaining to Indian market. This particular survey will be giving you an idea that where we are from the Indian side. And as a team of your classmates, if you come forward, and one of you can take up one particular project stating that a sort of manufacturing a simple single motor being manufactured at NBKR will definitely fetch you a lot. Okay, so maybe by evening you try to identify all those things. By tomorrow morning, you please send those details to me. Maybe through WhatsApp, that is more than sufficient for me. Anyway, these are the advanced variations of brushed DC motors. In this type, gear assembly is attached to the motor. That is what we are able to see in the cut models in the first one and the third one altogether. The speed of the motor is measured in rotation per minute. That is obvious. Gear assembly is used to increase the torque by reducing the speed. On this particular aspect, we have already had some discussion up to some extent. This enables the motor to rotate at a stable condition. Obviously, once we have maintained geared contact, whatever the RPM with which the input shaft is trying to rotate, since it has been that motion has been transmitted to the output shaft through gearing, there will be no slip, and because of that the stability with which the input shaft is rotating, with the same stability, even the output shaft is going to rotate. That way you can imagine. Then motor can be either stopped or increase the speed. So the idea over here is the moment you have stopped the supply of power, at the same instance the motor is going to be stopped at the same location instead of with the load. That you please bear it in mind, because if you try to consider the entire robo, it has got so many arms. So all those arms are actually having different activators. Suppose at a particular location, say for example, you have got these two things, and say this particular arm is actually having certain load, and you are having an actuator here. You are trying to rotate like this. At a particular instance, say this is the initial position. At this instance of its movement, if you stop the motor with the load, the motor as well as the arm is going to be stopped at that location only instantaneously. So that is the beauty of this. And of course, higher the input voltage, higher is going to be the speed. That's the reason speed that is attainable with 12 volts. 1 second, 1 second, please. Let me continue my discussion. There is no problem. The speed with which we are trying to rotate, the speed with which we are trying to rotate, that is actually controlled by the voltage. So if you supply 12 volts, if you are supplying 12 volts, that means that if you are supplying 12 volts, that means that corresponding to that, the speed is going to be. If you reduce that particular supply of that power, I hope I am audible. Am I audible? I hope I am audible.
Sir, voice is somewhat low, sir. You are audible, sir, but voice
Okay,
is
okay,
somewhat low, sir.
no problem, no problem. I wanted to sanitize my hands, and I got up. Okay. Anyway, if you try to consider the supply of voltage, because regulating the voltage is totally in our hands. Regulating the voltage supply is in our hands. We can regulate, and because of that, by regulating that particular voltage, RPM of that motor can be altered. So now to give you more clarity on that, N12 volts means RPM with the 12 volts is always greater than the RPM with the 6 volts. That's what has been stated. Okay. Let us move to the next slide. The gear ratio, this expression is known to us. D2 by D1 equal to number of teeth on wheel 2 divided by number of teeth on wheel 1, which is equal to torque of wheel 2 divided by torque of wheel 1, which is now equal to RPM of wheel 1 divided by RPM of wheel 2. So this is actually giving us a clear-cut indication that both RPM and torques are inversely proportional. Okay, even the diameters and torques, even the diameters and RPMs are inversely proportional. Even the number of teeth and RPM are inversely proportional. So sometimes as a part of what do you call a competitive examinations, this can come as a question. And the next few lines, 1, 2, 3, 4, 5 lines, are trying to give us how the RPM is going to be reduced. Once the RPM has reduced, by what extent the torque is going to be raised. That also we will be able to, we'll get more clarity on that. Now let us move to the stepper motor. The name itself is actually indicating that the total RPM is going to be implemented in steps. Say 360 degrees, one revolution. That 360 degrees of revolution can be controlled, regulated, and implemented in multiple steps. Maybe in a step, 1 degree if you try to control, then 360 steps are required to complete one full revolution. The step size can be, step angle can be varied. It can be 0.5, it can be 1, it can be 2. If you try to consider the step angle with 2 degrees, then for 1 RPM, there are going to be 180 steps. Okay, so 15 degrees to 30 degrees to manipulate, story is very, very easy. So 30 degrees, if you try to manipulate, what happens? Then out for covering 360 degrees, 360 by 30, then 20 steps are required to complete one revolution. Okay, so how that is happening? Literally with an animated wheel, you are able to visualize the things on this. Now, like the servo motor word has been used, like in servo motor, you are not going to divide the total RPM into multiple steps, but you have a mechanism to specify an angle, and you can make that particular servo motor to rotate with that particular specified angle. Okay. So anyway, stepper motor, when you want to classify, it comes under brushless, synchronous, and electromagnetic devices. So we have seen earlier brushless DC motor. So your stepper motor comes under that. And this is anyway electromagnetic device. Why it has that name has come? That is actually making use of magnetic field and the digital pulses. Digital pulses in the sense, in order to make that particular motor to on run condition, this digital switch solid state device should be kept in on mode. And those solid state devices can run only in two modes. One is on mode, another one is off mode. So digital name has come. That on and off will be noticed by 1 and 0. Okay, so binary representation, either run 1 or 0. If it is 1, maybe on. If it is 0, that is going to be off. So with that inputs, it can understand it is going to run and stop. Okay, so that is the reason why these digital pulses and that particular pulses again are going to work with modulated pulse width. Okay, PWM, that statement also comes somewhere here. We will see when it comes to that particular location. Anyway, so this actuator uses a step method to perform a particular movement in application. Say for example, you have you have a stepper motor wherein its step is being regulated by 1 degree, say. Then to cover 30 degrees, 30 steps it has to be instructed to move. That way you try to visualize. Okay, the core of the actuator consists of 4 magnetic points. Anyway, this particular number 4 is not applicable for the figures whatever I have tried to show. So this particular 4 I need to change. I will make a note, I would have changed, or I will try to change. Slide number 40, 4 steps. This I have to change to match with the figures whatever I am trying to use. The points are set against a set of teeth around the core of the motor. You can see here in the animated image whatever we are having. See this. These are all rotating. This is the core. For that particular core, there are teeth which are colored with blue and red. Okay, those are all the teeth that have been accommodated on the rotor. And you have got few more teeth. Say for each and every, there are 1, 2, 3, 4, 5, 6 magnets or the teeth that have been attached to the stator. Even for that particular stator teeth, these 3 are the subteeth. That way you can imagine. Okay, the points are set against a set of teeth around the core of the motor, and as each step takes place, the magnets moves in a circular motion and fit into each teeth. How that fitness is going to happen, let me go to other slides. Then maybe by taking the reference of axis, I'll be able to. Okay, so the last point, you may not get total idea right now, but altogether you should understand one thing, that rotation or that particular step is going to be regulated such that, okay, the magnets move along a circular motion and tries to fit into each tooth. So how they are going to fit into those tooth, we will see in the next portions of this slides. Okay, now, sorry, let us see here. Generally, the most common motor used in a stepper motor actuator is the 12-volt stepper motor. This is a common statement. This motor provides enough power to enable 100 steps in an application. Means 360 by 100, 3.6 degrees. A controller is attached to the motor in order to make the magnets to work. In the earlier sketch, you have seen, see, alternately outer ring colors are changing. See, based on the colors being changed on the outer side. Accordingly, at that time only, this inner rotor is actually trying to rotate. So that is what is actually being noticed over here. Like all motors, stepper motors also have stator and rotor. See, this is the rotor and this is the stator. The number of coils will differ based on the types of stepper motor. Okay. The number of coils whatever we are having are actually depending on the type. So based on that, they are going to classify with a subname. Okay. The rotor consists of metal poles. So this particular rotor is actually having 1, 2, 3, 4, 5, 6. Maybe they are the metal poles. And each pole will be attracted by set of coils in the stator. So these poles, say 1, 2, 3, 4, 5, 6 are the number of poles, metal poles, what all accommodated on the rotor. Whereas in the earlier sketch, all these projections, alternately blue and red color, have been showed, which are rotating. Those things have been showed here. And that is actually getting attracted by set of coils in the stator. See, these are the coils in the stator. Coils in the stator are going to be energized alternately. See, whenever this has reached the color, whenever this one is actually with the color, that indicates that that has been energized. So for one instance, that has been energized. The moment you have energized this, pertaining to the teeth on the rotor will come attracted and come and stays over there. Okay. That is what has been stated over there. The stepper motor showed here is with 8 stator poles. See, let us count A, B, C, D. Okay, A, B, C, D, A dash, B dash, C dash, D dash. Okay, A dash, B dash, C dash. That way you can imagine D dash. Altogether, 8 stator poles are there, 6 rotor poles are there. Then, same image we have tried to use here. See, if you observe carefully, they are arranged in terms of coil, pairs like A dash and B dash, so on. That's what I said. A dash, B dash, C dash, D dash. Likewise, they are all. Each of the coil pair form an electromagnet. So A dash is a pair of electromagnet. B dash is another pair. C dash is the third pair. D dash is another pair. And they can be energized individually using a driver circuitry. So how that alteration is happening for energization? There is a circuit, and that particular circuit is actually trying to take care of that particular alteration. Maybe if situation demands, I will try to show even that there is no problem in the forthcoming classes. When a coil gets energized, it acts as a magnet. See, this is the coil that is actually getting energized. Colors are changing. That is going to act as a magnet. Okay. And the rotor pole gets aligned to it. Rotor pole మీద ఏమన్నాయి మళ్ళా అక్కడ పెయిర్స్ ఉన్నాయి. అక్కడ ఉండే మ్యాగ్నెట్స్ కూడా ఐరన్ కోర్ అది ఎగ్జైట్ అయ్యి మ్యాగ్నెట్ అవుతుంది. సో అప్పుడు మళ్ళీ అది రిలవెంట్ పోల్స్ వస్తాయి. అంటే ఏంటి, అన్లైక్ పోల్స్ గెట్ అట్రాక్టెడ్, నార్త్ పోల్ అండ్ సౌత్ పోల్ అవి అట్రాక్ట్ అవుతాయి. అవి రెండు ఆ టీత్ అలైన్ అవుతాయి. ఆ టీత్ అలైన్ అయ్యే ప్రాసెస్ లో చూడండి ఇక్కడ అంతకుముందు ఏంటి, వన్ వాస్ మేటింగ్ విత్ ఏ డాష్, నౌ ఇట్ హాస్ మూవ్డ్ టు అదర్ లొకేషన్. అక్కడ ఏమైంది, అది దట్ మేటింగ్ వాజ్ యాక్చువల్లీ that mating has taken place to this. 1 second, please. 1 second. Only one. అయినా సాయి పాస్పోర్ట్ 1 2 కూడా ఏం చేస్తున్నాం రామకృష్ణ సారు నీకు కూడా ఏం చేస్తాం పాస్టర్ చెప్పి రామకృష్ణ సార్ ఉంది కదా వాళ్ళు కంటిన్యూ క్లాస్ వాళ్ళు కూడా పోలేదు. Sorry for the trouble. So if you see this particular sketch earlier, okay, okay, so it is actually not short. So this was matching with A and 1 will be in line, means A dash and 4 would have been in line. Then because of energizing the next pair, what happens is the teeth 1 and 4 gets moved and the teeth 3 and 6 get matched with the link BB dash. That time 1 and 4 will be indexed or will be moving by step of 15 degrees. That's what you should understand. Means 8 poles being arranged on stator, 6 poles being arranged on rotor will be giving a step size of 15 degrees. That's what you should understand. Similarly, by energizing using the coils in a sequence, we can make that particular rotor to rotate in small steps. In this particular case, a step size of 15 degrees, and that is how we can ensure to continue a complete rotation. Based on the construction, stepper motors are 3 types. They are variable reluctance stepper motor. So this is the question being asked in the recent university examination, how the variable reluctance stepper motor is going to work. Okay, so maybe as a sort of answer for that, working of stepper motors, you can explain till now whatever has been discussed. And this is one type, variable reluctance stepper motor. They have iron core rotor. Even for that, same thing I believe. Okay, then which is attracted towards the stator poles and provide movement by, this is the technique, minimum reluctance between the stator and the rotor. Minimum reluctance in the sense, minimum resistance, minimum flux resistance. See, magnetic flux is going to be generated. Out of that, there are going to be few locations wherein minimum resistance is going to be offered. Through that, the power is going to be transmitted or magnetization is going to be contributed, and that is going to contribute towards the motion of the rotor. So this is only the word what is going to add to the stepper motor, and this is only the difference what we are going to show at the time of explaining variable reluctance. Okay, let me see in the next slide, did I put any other information or not? Let us see. Okay, so anyway, next step is actually permanent magnet stepper motor. They have permanent magnet rotor. Now in the earlier case, generally, okay, variable reluctance case, metal core was used. Okay, whereas in the case of permanent magnet, the core being used is actually, rotor being used over there is actually made up of permanent magnet. They are repelled or attracted towards the stator according to the pulses applied. That is obvious. And hybrid synchronous stepped motor. I think I have prepared some content. I don't know whether I missed. Okay, that is coming. Anyway. Okay, this is giving some introduction to those areas, and of course, went on discussing in detailed manner in the next slides. Hybrid synchronous in the sense, they are going to work with the combination of variable reluctance and permanent magnet stepper motors. So stepper motors are also classified as unipolar and bipolar based on the stator windings. Stator coils on this type of bipolar. Stator coils on this type of motor will not have a common wire. The driving of this type of stepper motor is different and complex, and also it is something like this. You are going to make use of a single pole or multi-pole. That is what you are trying to. Okay. Okay. So based on that, unipolar and bipolar are going to. And of course, few advantages have been listed out. They are high, very high with accuracy. You have got pretty good flexibility, and they are pretty stable. Because the moment you have stopped with the load, it is capable to stop at that location. So unless otherwise you have such a stability, it is not possible for you to handle those situations. Cost saving is also, there is no need for measurement because you are having a control on the step size. Because of that, there is no further requirement of measuring it back. So because of that, you are able to reduce the cost. So those are some of the advantages at that instance have been. Maybe you can see here, permanent magnet type, 30 degrees to 3 degrees step size you can have, and variable reluctance and hybrid type if you go, you can reduce it even up to 1.8 degrees per step and smaller. Even smaller than them also it is possible. Okay, so only to give you some idea, this comparison table has been given. Now let us see the detailed structure of variable reluctance stepper motor. Rotor of this type of stepper motor aligns in a particular position with the teeth of the excitation pole in a magnetic circuit wherever minimum reluctance exists. Okay, so wherever minimum resistance being offered to the flow of flux lines exists, that way you try to. Maybe in order to give you a comparisonal understanding, suppose if you try to consider the current flow. Current flow, when you try to consider, its motion is going to be confined to minimum resistance. So suppose you have current flow being permitted to flow through two paths. One is with minimum resistance, another one is actually with maximum resistance. If you permit the current to flow through these two, wherever the minimum resistance is offered, through that maximum current flows. Because of that reason only, if you try to touch the cable, resistance of our body is very, very low. Because of that, we experience the shock. Because the power, instead passing through the cable, it passes through our body. Because of that reason, we experience the shock. On the similar grounds, even over here. Whenever power is supplied to the motor and exciting a particular winding, it produces the magnetic field and develops its own magnetic poles. Okay. So in a simple line was showed in the earlier slide that was explained with the support of technical words. It was explained and written in an exaggerated manner. Due to the residual magnetism in the rotor magnet poles, it will cause the rotor to move to a position so as to achieve minimum reluctance position. It is something like, say, you have given a moment. Suppose you have pushed a wheel. What happens? That wheel will continue its travel. For what reason? There is either the moment whatever you have given is its continuity, rather its motion is going to be continued unless its driving force is more than the resistance force. On the similar grounds, even here, okay, so because of the it looks for the minimum reluctance position, till then it continues its motion and it stops. That itself is the step size. So one set of poles of rotor aligns with the energized set of poles of the stator. This particular statement is on par with the functioning of a simple stepper motor. At this position, the axis of the stator magnetic field matches with the axis passing through any two magnetic poles of the rotor. This, I believe, I have a sketch here. See here, A dash is the beginning position. That time theta equal to 0. You have energized next set of stator poles. That time what is happening? See, that is going to match 2 and 4, but this 1 and 3 is going to be indexed towards clockwise. Okay, so because of that, this is actually the step size now. So means 1, 3 reference line has been taken that was in line with A axis. Then when you have given, you have energized the next stator poles, what is going to happen is that will definitely try to match with the poles of the rotor and the stator, and that is going to contribute the rotation of the 1 and 3 poles, and the reference location of 1 3 prior to that is going to be compared, measured with the new position. That angle, if you try to measure, that is 30 degrees. Okay, so that is how next inlet, if you next input when you give, that 1 and 3 will come in line with the CC dash. That time this angle, if you try to measure, 30 plus 30, and next input if you give 30 in the first, 30 in the second, 30 in the third, altogether 90 degrees. That is how its rotation is going to be continued. Okay, so now here you can see switch 1, if you short, that is going to match with the AA dash, and switch 2 when you short, and switch 1 you are going to open, and switch 3 also you are going to put it in open. Then alternately, switch 1 if you want you can short it, switch 2 if you want you can short it, switch 3 you can, if you want you can short it. Accordingly, see, you can see here A, B, C are there. Then again when you short A, that is going, this is going to become A, and that is going to become A dash. That is how the excitation and things are going to manipulate. And the same thing has been explained here. See, when the phase AA dash is given to DC supply by closing the switch S1, the winding becomes a magnet, okay, which causes one tooth to be north and the other to be south, and the stator magnetic axis lies along these poles. Because of the force of attraction, stator coil's north pole attracts the nearest rotor tooth of the opposite polarity. And the north pole is opposite and the south polarity. Okay, so మీరు ఇది యాక్చువల్గా నేను ఎక్స్ప్లెయిన్ చేయటం నాకు, నేను ఒకసారి ఆల్రెడీ మీకోసంగా చదువుతూ కొంచెం ప్రాక్టీస్ చేసినందువల్ల it has become a sort of easy. Maybe when I re-explain it again, it will become permanent for me. What you need to do is, you please go through this context immediately today itself, so that since we are new to this particular field, once you read once or twice, we may get some queries, or when you have got one query, read it again, you may get another query, read it again. So do it thrice or 4 times, then with the support of this particular figure, you will become familiarity with the terms, what to use and how to use, and you will start writing your own way. Okay, what we see in the examination is also your understanding on that. Okay, same thing has been explained. Let the phase BB dash, you have with S2, opening S1, then B1 exercise. So if you learn the content and understand the content earlier, that is going to give you the understanding on this. See, ఇక్కడ మీకు స్విచ్లు చూపించాను కదా ఎంతమంది స్లైడ్లో, ఇవి ఈ 3 స్విచ్లు, అవి కూడా one of the user have tried to, one of the author has tried to animate. ఇక్కడ చూడండి మీరు, ఇక్కడ ఇది అనేది ఈ మూడిట్లోనే మారుతూ ఉంటుంది చూడండి, ఈ 4 ఫేజుల్లో మారుతా ఉంది చూడండి. జిఎన్డి, దట్ జిఎన్డి లొకేషన్ ఈజ్ వెరీ ఓకే. సో దానివల్ల యాక్సిస్ ఎలా మారుతుంది, ఇండెక్సింగ్ ఎలా జరుగుతుంది, సో మీకు ఇండెక్సింగ్ యాంగిల్ ఎంత, ఆల్ దట్ యూ కెన్ విజువలైజ్. మేబీ see, if you want me to explain on these grounds on board, it would have been not possible for me. Since we are meeting online, so I am trying to give you all possibilities that are possible for you, for me to understand and present it for you, which is going to give you an easy understanding, has been made possible to you. Okay. ఇక్కడ చూడండి, ఇక్కడ ఏంటి, 6 poles on the stator, 4 poles on the rotor. అదే ఇక్కడ తీసుకుంటే 3, 6, 2, 8 poles on the rotor, 6 poles on the stator. అంటే మనం రకరకాలుగా కూడా కంట్రోల్ చేసుకోవచ్చు. దట్ ఈస్ గోయింగ్ టు గివ్ యూ ఎన్ ఇండికేషన్ ఆన్ ది, అంటే మీకు స్టెప్ సైజ్ మార్చాలి అంటే మీరు ఈ నెంబర్ ఆఫ్ పోల్స్ ఆన్ ది స్టేటర్, You can play with number of poles on the stator and number of poles on the rotor మార్చుకోవచ్చు. సరే, వేరియబుల్ రిలక్టెన్స్ స్టెప్పర్ మోటార్లోని ఇంకొకటి ఉంది, మల్టీ స్టాక్ అని. అంటే మనం ఇంకా కూడా స్టెప్ సైజ్ తగ్గించాలి. అంటే ఏంటి, అప్పుడు ఏం చేస్తాం మనం, దిస్ ఇస్ హౌ వీఆర్ గోయింగ్ టు సీ స్టాక్ ఏ. అంటే మన ఇక్కడ ఈ కేసులో ఏంటంటే ఒకటే రోటారు, ఆ రోటార్కి టీత్, ఒకటే స్టేటర్, దానికి సంబంధించిన టీత్. ఇక్కడ ఏంటంటే ఆ రోటార్ని ఎక్స్టెండ్ చేస్తాడు. సి దట్ రోటర్ హ్యాస్ బీన్ ఎక్స్టెండెడ్, హియర్ సమ్ స్టెప్స్, సమ్ టీత్, హియర్ సమ్ మోర్ టీత్, హియర్ సమ్ మోర్ టీత్. అట్లాగే స్టేటర్లో కూడా ఇక్కడ కొన్ని టీత్స్ ఉంటాయి, ఇక్కడ కొన్ని టీత్స్ ఉంటాయి, ఇక్కడ కొన్ని టీత్స్ ఉంటాయి. ఇట్లా తీసుకుంటే ఏంటంటే దాన్ని మనం స్టాకింగ్ అంటాం. చూద్దాం ఇక్కడ ఏంటో, మనకు ఒక క్యాలిక్యులేషన్ ఇచ్చాడు ప్రశాంతంగా. The step angle of this three-phase four-pole rotor teeth stepper motor is 360 divided by number of poles multiplied by number of phases. That is how he is getting 30 degrees. దాన్నే మనం జనరలైజ్డ్ స్టేట్మెంట్లో రాసుకున్నాం. అంటే మనం ఇక్కడ డిజైన్ ఏం చెయ్యం, కానీ వీలైనంత వరకు ఇది ఎలా వచ్చింది అనేది ఒక ఎక్స్ప్రెషన్ మనసులో పెట్టుకుంటే రేపు మనకి ఏదైనా సిచ్యువేషన్ వచ్చినా సమ్వేర్ వి హావ్ లెర్న్డ్ అన్న నమ్మకంతో విల్ బి ఏబుల్ టు వర్క్ ఇన్ అవర్ వర్కింగ్ ఎన్విరాన్మెంట్ ఇన్ ఏ కాన్ఫిడెంట్ మేనర్. ఓకే, ద స్టెప్ యాంగిల్ కెన్ ఫర్దర్ బి రెడ్యూస్డ్ బై ఇంక్రీజింగ్ ది నెంబర్ ఆఫ్ పోల్స్ ఆన్ ది స్టేటర్ అండ్ ద రోటర్. దిస్ ఇస్ వాట్ ఐ సెడ్. ఈ 30 degrees తగ్గాలంటే ఏం చేయాలి, ఈ డినామినేటర్ పెరగాలి. డినామినేటర్ పెరగాలంటే ఏమేమి ఉన్నాయి ఇక్కడ, నెంబర్ ఆఫ్ పోల్స్ ఆన్ ది రోటర్ అండ్ నెంబర్ ఆఫ్ పోల్స్ ఆన్ ది స్టేటర్. వీటిని పెంచుకుంటే డినామినేటర్ పెరుగుతుంది, ఆటోమేటిక్గా అది మనకు స్టెప్ యాంగిల్ని మారుస్తుంది. In such case, motors are often wound with traditional phase windings. This can be achieved by adopting different construction of stepper motors such as multi-stack arrangement and reduction gear mechanism. So, రెండు మెకానిజమ్స్ వాడుతున్నాడు. ఒకటి మల్టీ స్టాక్, చూడండి ఇది ఒక్కటే వాడితే సింపుల్. అలా కాకుండా ఏంటి, మూడు ఉన్నాయి, స్టాక్ ఏ, స్టాక్ బి, స్టాక్ సి. సో మోర్ దెన్ టూ వన్స్ యూ కమ్ అక్రాస్, దట్ ఈస్ గోయింగ్ టు బి రెఫర్డ్ యాజ్ మల్టీ స్టాకింగ్. దాన్నే ఐసోమెట్రిక్ వ్యూలో ఇక్కడ చూపించాడు. సో నెక్స్ట్ వెరైటీ ఏంటి, పర్మనెంట్ మ్యాగ్నెట్ స్టెప్పర్ మోటార్. పర్మనెంట్ మ్యాగ్నెట్ అంటే మీరు ఫిజిక్స్లో నేర్చుకున్నారు, ఫెర్రైట్ అని. పర్మనెంట్ మ్యాగ్నెట్ అంటేనే మీరు ఫిజిక్స్లో నేర్చుకున్నారు. వాట్ ఈస్ దట్? దట్ ఈస్ ఫెర్రైట్. ఫెర్రైట్. ఓకే, సో ఐఎమ్ నాట్ షూర్ వాట్ ఈస్ ద టైమ్ నౌ. Did we cross 9:40? One of you can unmute and speak, so yes, that sir. I will.
9:42, sir.
Okay, I'm sorry. I'll stop now. I'll stop my presentation. I'll stop my presentation. I'll stop my recording also. 1 second.